Today we're going to talk about radian measure, and so far we've only really talked about measuring angles in degrees, and radians is another way that you can measure angles. And typically radians are used in more theoretical mathematics, where it's preferred to treat trigonometric functions as functions with domains of real numbers rather than domains of angles. So let's talk about what a radian is. The definition of a radian. I've written it right here. A radian is an angle with its vertex at the center of a circle. So let's draw an angle with its vertex right here at the center of the circle that intercepts an arc equal in length to the radius of the circle. So let's draw our angle in standard position. We always draw the horizontal first. And if we take our radius, the arc has to be equal in length to the radius of the circle, and we measured this radius right here, and we laid this radius across our circle, and we drew the terminal edge at the end of the length of the radius. This angle right here would measure 1 radian. Okay, so that would measure 1 radian. If we continued to lay that radius across our circle, this angle from standard position here would measure 2 radians. If we continued to lay it across our circle again, it would end up something like this, and from standard position, that would be 3 radians. Let me mark that, because this is basically where pi comes from. You see this little piece that's left over right here? That is your 0.14 decimal portion of pi. So we have pi radians that actually lay from, in standard position, pi radians from 0 degrees to 180 degrees. And that's why your circle actually has 2 pi radians going all the way around it. So let's talk about how to convert back and forth from degrees to radians. And this is probably a third of the homework assignment that'll be due on Wednesday. So when we have, we're so used to taking measures in degrees right now, and if we're going to work in radians, we should know how to convert back and forth between degrees and radians. So if we have, say, 45 degrees, and we want to convert this into an angle in radians, what we would do is we would multiply by pi over 180 to get its measure in radians. So when we calculate that out, 45 goes into 180, 1, 2, 3, 4 times. This would give us a measure in radians of pi over 4. If we have negative 270 degrees and we wanted to convert that to radians, we would also multiply by pi over 180. And let's see, what goes into both 270 and 180? Well, definitely 10. So let's go ahead and take that 10 out. And then 3 goes into both of them. And 3 goes in again. So negative 280 degrees is negative 3 pi halves radian. And the last example that I'm going to do is I will go ahead and convert 249.8 degrees into radians. And even though this is decimal degrees, we're still going to multiply by pi over 180. And this is something that you would plug in your calculator to calculate out. And when the calculation was done, this would approximately equal 4.360 radians. Okay, so let's talk about how you know the difference between degrees and radians. If I wrote down, let's see, 12 versus 12 degrees, this one it's obvious that it's degrees because there is a degree sign right there. This one, there is no degree sign. Therefore, it is in radians. And that's why at the beginning of trigonometry I said it's very important that you always write the degree sign, because if you do not, whoever is looking at your work is going to assume that you're writing the measures of your angles in radians. So always make sure that if you're writing the measure of an angle in degrees, write that degree symbol. Otherwise, leave the degree symbol off and everything is assumed to be in radians. All right, so we saw how to convert degrees into radians. Let's go backwards and convert radians into degrees. So again, to convert degrees into radians, you will multiply by pi over 180. To go backwards, you multiply by the reciprocal, 180 over pi. So let's start off with converting 9 pi over 4 back to degrees, and we will multiply by 180 over pi. Okay, our pi's will cancel out, and we will be left with, let's see, how many times does 4 go into 180? I know that it's going to go in, let's see, 45 times. So 9 pi over 4 is going to be 9 times 45, which is 405 degrees. So that's a full revolution around our circle and 45 degrees more. So it would end up in the first quadrant. All right, so how about negative 5 pi over 6? How many degrees is that? Well, we will go ahead and multiply by 180 over pi. Our pi's again will cancel out. 6 goes into 180 30 times. And when we're done calculating, we have negative 150 degrees, which would land us in, let's see, yeah, negative 180 degrees or 150 degrees, which would put us in quadrant 3. And then our last example would be a calculator example, and I don't have a calculator to show you, but if we wanted to take 4.25 radians, and I want you to visualize this, if 3 radians almost go around half the circle, 4.5 radians would be somewhere in quadrant 3 on your circle. So after visualizing that, when you plug this into your calculator, you should get the degree measure of an angle in quadrant 3. And if you do it correctly on your calculator, you should get approximately, and I should write the approximately symbol, 243.5 degrees, which is in quadrant 3. So you can always check your work. If you draw out and map your radians along your circle, you can always check your work. So how many radians go around your entire circle? Well, if half your circle you have pi radians, well then for a whole circle, your whole circle will be 2 pi radians, and that's where we get 2 pi from. Okay, and that is it for this video. You guys can go online and do the quiz really quickly, and you can even start your homework that is due on Tuesday.